So we've just got some sodium ethanoate supersaturated solution, and we're going to provide some crystals here, which will act as nucleation sites for the sodium ethanoate, as used in hand warmers and so on. So we're expecting this to go up to temperature, so we start pouring now, and as you can see, create a stalagmite, and notice the temperature's gone from 18 up to 30. We could carry on, but other people are wanting that to try. You see the temperature climbing all the time, so nice exothermic reaction, and again, very easy to demonstrate. This is just to establish how I've set up the microscope. I've got a FlexiCam type camera, which is used to take the image onto a screen. As you can see, there's not an awful lot of definition on that screen. However, that can be vastly improved by turning this into a polarizing filter. I have two standard Polaroid films. One goes over the LED, the other is put on top of the slide, which I've got on here, which has got some crystals in, and then it's a bit of improvement. But if I now rotate this so that so I get a minima of light coming through, but effectively a black field, the quality of the image becomes really a lot clearer. I'm now going to create a slide to put on the microscope. To do that, I'm taking some crystals of the stalagmite, the sodium ethanoate, and putting that between two glass plates for a microscope slide. I'm then going to heat them up using a hairdryer on its hottest setting, and I want to heat it as evenly as possible and over both sides. That's going to get the energy into the crystals so that it becomes liquid and shows that there's no extra water being added, and all the water is coming from the water of crystallization. So this is going to be very noisy, and probably you'd want something in the background just to distract from the noise. This will of course be switched off in video. So right, once melted, we're ready to go. So I have this is actually cooled down, so I'm going to reheat it just to show you how to work this. Now, just making sure everything's ready to go on, and this is all frosted through. So I'm heating now away from my fingers, so my fingers don't get too warm, and watching this so as to see when it's melted. Using the hottest setting that I can on the hairdryer. I have to work reasonably quickly, ensuring the slide is held firmly down there. Polaroid on the top, and then adjust the bottom to get maximum dark field. And just wait for crystallization to occur. Well, a better crystal probably to use would be salol. I've got this between two slides again. You can use this over and over again. Salol will go an awful lot less quickly. So again, heating up, but it doesn't need to be quite as hot. And you can talk about how you can heat it, so you can heat top and bottom to give you a more constant heat, therefore bigger crystals, or just heating one edge and letting it flow in from that edge, well, towards that edge as it cools, giving you smaller crystals. So heating up. Liquid, put it onto the stage, and I'm just going to try and look and see where some crystals are going to start from. It looks as if it's going to come from that edge. onto the top, and then adjust the bottom one to get dark field. And you can, if you want, try to, if you see any on the slide, any crystals moving, forming, you can move your slide to actually get to that area. Unfortunately, the contrast on this microscope means it's a bit whitewash, but if you put get the class to have a look afterwards when you put the normal slide back together, or get them to do this themselves. Prep room again, and I'm just going to show you what I'm going to be using to take the more detailed images, which is this camera mount here, which actually can be used on telescopes or microscopes or spotting scopes or anything like that. You can get them for about £12 from Amazon.